it. I can't handle it anymore.
Mr. Hall,
we're
can you
live.
follow me on Instagram just so you can vote on it?
Just ask what this other.
Random lady.
This is the beginning of the heart of everything that
It
matters.
shows a lot about your character.
It does. It says a lot. Okay. So, let's go over a quick
Yeah, we should do.
little example
Can we
from.
do 8 and 10? Those are very troubling to me. Yes.
Well, 8, you just expand it and look at what the coefficients are. Right? So for 8, you're just going like this. You're like, what's marker's head? What would Julia's head? Oh, what a
This.
shot, right, Julia? No, Julia, that was nothing but that. Okay, so you guys have figured it out. You can expand it. So you expand it just like you've been doing on number 7. And then at the end, you'll have some amount of log p's, some amount of log x's, and some amount of log t's, and then that's your answer to A, B, and C is what it's going to be. For 10, what you're doing is going like, take the first one. It says log base n of q squared. So based on what we've been doing, what do you think we're going to direct our attention towards?
Q squared.
Yeah, especially this 2, right?
Isn't it just gonna go in front?
Yeah, so this is equivalent to 2 times log base n of q. Now, do we know what log base n of q is?
10.
It's 10. So the answer is what? So what this question is talking about is if you know what, if you have some log value.
So B is 70.
So yeah, for example, I mean, here's one we know, right? What's log base 2 of 8? 3. Right? So what's log base 2 of 8 to the 50th power? You have to know what 8 to the 50th power is?
150.
Yeah, the answer is 150.
Oh, yeah, that makes sense.
But then let's see.
The intermediate step here is that the 50 can be pulled out, right?
Yeah.
50 times log base 2 of 3, and we know log base 2 of 3 is 8. Sorry, log base. Sorry. My bad. Again, 50 comes out. You got.
Okay, but why is it? Oh, never mind. I was gonna say why is it? I lost it.
If you remember the question, just ask me later.
I was thinking you were doing B just there, and so.
This is an example of how this is applied. So this is just a more abstract example because I mean log base n of q, n and q could be anything, but just suppose you knew that log base n of q was 10, you would know all those other answers. Just use your log properties. Okay. 12 is the same thing. 12 is just almost exactly like one of these. Like for 12a, you don't have to know what 32 to the 100th power is. You just have to know what log base 2 of 32 is.
Which is
2, 4, 8, 16, 32.
5.
2 to the 5th makes 32.
So it's 500.
Exactly, yes. Now, for 13,
Is it log base?
this is all just log properties. This is all. Does anyone know what log base 3 of 36 is? So I'm talking about 13a here. Does anyone know what that is as a decimal? I hope not, because if you do, you're some kind of like genius, like way beyond high school mathematics. But you probably do know. Can you get a guesstimate of just roughly how big is this number, log base 2 of 36?
3 of 36 or 2?
Did I say it wrong? Log
You
base
said
3.
two.
Oh, sorry. Log base 3 of 36. That's a
3 goes into 36. Is it what, like
I don't even know what to
Well, it
do
goes
there.
in, usually when you use the word goes in, and we're
That's
talking about
wrong,
division,
but-
we're not really doing division here. What,
it's
Kayla?
like
Hold on, Kayla had something.
I don't know, I was just like 398.
3, 9,
and then 27.
27,
So it's like
81.
3.1.
Or 3.
Very good, very good. You guys get that? Because we know that 3 to the third power is 27. 3 to the fourth power is 81, right? So we know that 3 to the third power is 27. 3 to the fourth power is 81. So therefore, there's something in between there. 3 to the 3 point something power would give me 36. Okay?
So it's like 3.1.
Well, here's the thing. So this is going to be 3 point something. How about this one? 3 to what power makes 4?
Like 1.2
1.12 or something.
1 point something. Yeah, does that make sense? 3 to the 1 makes 3. 3 to the 2 makes 9. So 3 to the 1 point
So it's
something
gonna
would
be
make
around
4.
2.
Right, so my final answer is going to be something 2. Here's some bad mathematics. 3 point something minus 1 point something. The somethings cancel out. You have 2. So the answer has to be 2, right?
Are you kidding me? That's how you
No, it's a
say.
joke, but the answer actually is 2.
Okay.
Here's why though. Well, that again, that's a joke because if you made this 4 a 5, it would still be a 1 point something, but the answer would not be 2. So, right? Here's another example of those like that bad math that actually ends up working out.
So this is exactly 2.
Huh?
This is exactly 2 what it works out to.
Con, can you put that away?
Yeah. And put it back together.
Yes. So why is the answer 2? What can I do if I have a log minus a log?
Division.
Division. So log of 36 minus log of 4 is the same as log of 36 divided by 4. What's 36 divided by 4? Log base 2. That's going to be the case on all of these. So I'm just going to use the symbol of most of the cases turning as a fraction and addition. There's a couple in there that's turning addition into addition. I got a couple more things. The other class I'll mention. Are you guys okay so far with long properties? So far, you can do every question up to this point. Log of A plus log of B. Log of A minus log of B. Is log of A over. And lastly, log of A to the B power is the same as B times the Okay, there's our review.
Yeah.
So any question you're looking at, you just have to do that. One of those, or one or a combination of those 3 problems. However, 14, we haven't talked about that yet. This is sort of an old school trick here. Because in the olden days, let's say you wanted to know, I'm gonna make one up here. Say you had what?
Said safety goggles and extra balls included.
For the seismic.
For the seismic accelerator.
My goodness.
I just read the box, that's all.
Yeah, there's a lot of things here that you could look at, but try to focus on what we're doing. So, what was I talking about? Oh, okay, so this is still a relevant trick now because with most calculators, if you wanted to know, for example, what's log base 5 of 73, that's kind of a pain, right? Because like, I mean, on your Snapchatters, I don't know if a modern Snapchat calculator has a convenient way to do log base 5 of 73.
It's like 2 point something, right?
Exactly, it is going to be 2 point something. So, and these calculators, they do have a menu that'll you can pull up and get a decimal approximation. But in the olden days, so if you're wondering, this number is roughly 2.6658 and a whole bunch of other stuff, roughly. So the way you would do that in practice is you'd have to use this thing called the change of base formula, okay? And so the interest here is beyond just, oh, this is how you used to do it back in the day. It's actually a pretty interesting property of logs. Don't miss this, Julia. I don't think you know this one yet. Or do you? Do you know change of base already?
No.
All right, pay attention. Okay, so I'm going to say this is equal to something, which I'm going to denote by a question mark.
Okay,
Okay.
step 1.
So the question here is, what if your calculator could only do like log base 10? How would you do this if you only had a machine that could do log base 10? What you would do is you would go, okay, this says that 5 to the question mark power has to equal 73, right? Everyone
Yeah.
understand that?
Mm-hmm.
Now, what's to stop me from taking the log of both sides? Nothing. So the log of 5 to the question mark has to equal the log of 73. Everyone feel okay about that?
Yep.
Now, what am I going to do with this question mark?
Move it.
Move it.
So would you
I'm
go
going to
like,
use this property, right? So now this reads question mark multiplied by the log of 5 is equal to the log of 73.
Can you just divide it and be like x equals log 73 divided by
Yep.
log
And
5?
divide both sides, which tells me that it turns out that this question mark is equal to the log of 73 over the log of 5. So if your machine is only capable of taking, now in the old days, they had like these tables. They'd have like a printed book that would tell you the log base 10 of say of all these different numbers. So you have to use that and then like a slide rule to figure it out.
that's crazy.
Now here's the thing, here's the trick. Was there any, I mean, I chose to do log base 10 at this step, but couldn't I have done any base I wanted, right? So the change of base formula is if you have log base B of A, that is equivalent to any base you want, so log base n of A over log base n. Does that make sense how this is saying the same thing as this?
Yeah.
We sure?
That is interesting.
Yeah, it is interesting how you can basically change your base just with division. So what's the point of that? Well,
There is no point.
yes, there is Mime. There's a point. Oh, you're killing me, Mime.
Why?
This has an interesting numerical consequence. Like, okay, look at this. The natural log of 49 divided by the natural log of 7. I'm going to use Mr. Computer to, hopefully this will be an interesting point for you. The natural log, so according to the computer, the natural log of 49 is roughly 3.891820.298. It goes on forever. And the natural log of 7 is roughly 1.945910149. It goes on forever. Now, what would happen if you divided those numbers? You could do an infinitely long division problem that takes an infinite amount of time. Wouldn't that be fun?
No,
Yes.
that's what how it is.
Okay.
The definition.
You might notice though, what's the relationship between those numbers? Did anyone see it?
It's gonna be like 2.
Is it half?
This number is half as big as this number. So let's see. How do we know that? Well, this, using the change of base formula, the natural log of 49 over the natural log of 7 is the same as log base. No, come on, look at this. Log base. See how
7 of 49.
log base 7 of 49. You guys see that? Do
Yeah.
you see how this is the same as that?
Yep.
Yeah.
If not, we gotta discuss it. This is an example of the change of base formula being used. Now, what's log base 7 of 49? 2. So that's nice. We get to avoid all that decimal stuff, but does that make sense? Everyone feel good about that?
Can we do like one more?
Sure.
Can we do like
How about you walk us through B?
me?
Yeah,
Why?
because you're the best.
I asked if we could do another one because I didn't know how to
Okay.
do it.
Okay, so the next one. It says log base 3 of 64 divided by log base 3 of 16. So what can I transform that? Here's a question for you. In this formula, when you look at the formula, what happens to these ends?
It kind of just
They
disappeared.
just disappear, right? Because the base,
So it would be log of 16.
log base
16.
16, right? So because the bottom number becomes the base
To 64.
of 64. So now the question is, what's log base 16 of 64?
It's like 1/2.
Let's figure it out. So the question this is asking you, 16 raised to what power would make 64? Now it's not an obvious number, right? Because 16 to the 1 power is 16,
16 to 2.
and 16 to the 2 power is clearly a lot bigger than 64. It's 256 if you're wondering. So it's going to be a fraction. These are both powers of what?
A quarter.
4.
Of 4. This is
4 to the second.
so 4 to the second to the question mark must be equal to 4 to the
Is it the Fourth? third?
yeah. Let's say you don't know your powers of 4 very good. It is
Yeah,
4 to the third. But these are both powers of 2, right? 16 is 2 to the 4th, and 64 is 2 to the 6th.
It's been a long day.
Yeah. Does that make sense to everyone?
Yes.
Do you see why the 4 and the question mark are multiplied?
Yes.
Yeah.
Because this is 2 to the 4 to the question mark, so you'd multiply the exponents.
So is it to the 3/2 power?
So that means that 4 times this thing must be equal to 6. So set those equal, and you get 3/2. So the answer to this question is 3/2. How are our feelies about that?
Okay.
Julia, feelie report? Feelies are A+.
Good enough.
Kayla, feelies? Reese? Good, thumbs up. All right. One last thing. Take a minute. Do 1 or 2 more of these change of base and the other ones on this page. And then we're gonna finish up class by going over some of these equation solving things.
I just,
Meg?
what? You just erased what I was looking at.
What were you looking for? It's been up there for a million years, Meg.
Is 3 to the 4th power 81?
What?
Is 3 to the 4th power 81?
Can't resist the temptation of almonds. You're not supposed to eat them apparently.
Why not?
They're bad.
What's
Well-
wrong with them?
I love a good almond.
Is it like comparatively to other?
They use a
That's
lot of
it,
water.
What?
Julie Cooley just told you.
They use a lot of water.
Oh, okay.
And it's like where they grow them is an area that's pretty arid naturally. So they have to like divert a whole bunch of water over there, I think. So
Why don't they just grow them in places that have water?
I don't know.
You should
Surprised me
ask
when I
them.
heard about it, but then I was looking at like there's a whole bunch of crops like that where they go. They have to like divert a whole bunch of water to grow them.
So
Anyway,
wait, can I use your help, Ashley? Yeah, because it's like 27 to what equals 81, and where'd you go from there?
So I made it into powers of 3,
So 3 to the third, and then 3 to the fourth.
and that's 4/3.
by the way, so you were talking about log base 27 of 81. It's a technique to do using your head. It requires you to kind of keep, it's not an easy technique, and it is equivalent to what I've shown you how to do it longhand. But what you do is if you're asking the question 27 to what power, let me just make a little box here. Once you realize that the answer is going to be a fraction, this is kind of what can go on in your mind. You go, well, these are both powers of 3. So how do I drop this number down to 3? What root do I take?
3.
The third root, right? So that tells me I'm taking the cube root. Then once I'm at the 3, once I have the 3 after cube rooting the 27, how do I jump the 3 up to an 81? I gotta go 4th power. So
Oh, that helps me a ton.
you see what I'm talking about? I mean, it works with anything. Like you go, oh, what's log base 8 of 32?
You just saved me.
You go, well, what root? These are both powers of what? So step 1 is what power? These are both powers of what? 2. How do I get my 8 down to a 2?
Are you doing D?
Take the cube root. Now that I got that 2, how do I get the 2 up to a 32?
So wait, can we do D though?
Is it 4/5?
Which one?
D.
Which one is that?
It's log 16 over log 32.
Oh, okay. So
Let's log 32.
log base 32 of 16. Okay. These are both powers of
2.
2. How do I get a 32 down to a 2? What root do I take? The 5th root. Does that make sense? How the bottom of your fraction, right? When I go 32 and I raise it to a power, if the bottom of that power is a 5, I'm effectively taking the 5th root of that number. Okay, so now 32 to the 1/5 makes 2. How do I jump that 2 up to a 16?
4.
4th power. So 32 to the 4/5 power is 16.
It's a game changer.
That makes a lot of sense actually. That helped me.
I really get these. They make sense.
Why are you
I will
laughing?
say for the record, I've mentioned this several times before, but I'm just mentioning it.
No, but like I just like this part of it makes a lot more sense than like
Good.
every other part.
No, I'm just laughing because when you get into this industry, sometimes you're like, well, guys, just remember, there's this slope is rise over run. Someone go, whoa, it all makes. Oh, I wish you had told me that earlier. And you're like, well,
What can you do?
I may have. Anyway, memes.gov. Okay. What does it take? Sometimes you have to hear something or see something a few times before you finally like, oh, I get it. With watching Inception, maybe you watch Inception the first time, you're a little lost. You watch Inception the second time, you're like, oh, let's see. These 3 layers down. You guys have seen Inception, yes?
No.
Hi.
Julie, you haven't seen it? Call your parents. Tell them. Julia told me something very alarming today.
You know what's alarming?
What?
How bad I am at exponents.
Okay. last thing of the day. These questions are sort of get into the heart of like, why do logs even exist? What is really the motivation? The higher up you get in math, the more you start to ask that question. What's the motivation for like creating this?
There is no
mathematical-
motivation.
You guys are killing me. There is, I mean, I'm talking about highly abstract stuff that, yeah, you can't, there's not even really an application for it yet, at least. This stuff, I mean, most of our technology is based on like mathematics that involve stuff like this. There's a very practical motivation for studying logs.
And Miss Caps wants me to be a computer coder.
They actually invented these for Guantanamo Bay.
Oh my goodness. Okay. So at the most basic level, logs, the reason the log exists is, you remember, the very first thing I told you was, if I say something like, oh, 2 to what power makes 8, now that one you just know it's 3, but what if you said 2 to what power makes 9? Okay, well now you need a way to describe what number does that. Well, log base 2 of 9, that's how you describe that number. Okay, so this question's asking, is there a number out there where if you go 60 minus triple e to double that number power, you get 0? Is that possible? The answer is yes, there is such a number. Let's look at how we describe that number. What is wrong? What?
I think it was
It's
short.
like just had a like amount.
What's wrong,
You
Aslan?
said that.
You just said so many numbers.
And I need to, guys, I need to remind you of something. Think back to the good old, when life was simpler, middle school time. And they said,
In middle
they
school, I
would
had
say something like, is it possible that 2 plus 5 times a number equals 9? Is that possible? And then you go, oh, subtract 2 from both sides. And you get to this point, you go, is there a number where 5 times that number equals 7? Yep, it's called 7/5.
You're making her cry.
This is a no tears zone. It's fine. It's not that scary. Watch. God, that's okay. First step.
Are you okay?
You're unstable or something.
You're doing fine, Aston. Don't worry.
I'm not doing great.
The first step is to subtract 60 from both sides, just like in the good old days. Okay.
We should make a
What step do you guys think is next?
Make him positive.
Divide both sides by -3.
Why are we not making them positive?
You could.
You're making her cry.
In any case, guys, you're gonna end up with this.
Aslan, are you alright?
We're
Okay.
fine. I'm pulling it
Make
together.
sense?
That was crazy.
Does that make sense? Okay.
Yep. Doing
So now I'm stuck, right? I go, oh, e to this power makes this. So what I do is I use log, right? Log base e, which you write as ln, log base e of 20 is equal to
2x.
2x. Great. You feel okay about that? Now divide both sides by 2, or maybe think of it as multiply both sides by 1/2. And you're done. There you go. That's what x is. So the number that turns out that does this is half of the natural log of 20. All right? What if I wanted to know roughly how big is that as a decimal? I would simply
Plug it in.
plug it into a calculator would tell me. Okay? We feel okay about that?
Yep.
Yes,
Can
Caleb.
you show the in-between stuff like that?
Of what? This to this?
Yeah.
I thought you were the one that said it. Divide both sides by 2, right?
Yeah.
Do you agree that dividing?
Why wouldn't
by-
it just be ln 10?
No. Okay, so natural log of 20 divided by 2. You can't do this division before the log is applied.
Oh, I see.
In order, when you write your order of operations, they kind of neglect. Really, it should be maybe PELM does, because Although I guess this technically it'll be a parentheses. But you do, so exponentiation and logarithms kind of are the same level. So you're gonna take this log before you
Can I
divide.
take a picture of that? I am
Yeah, me
gonna
too.
definitely have some troubles with these.
What? Picture of what?
The board.
It's the,
I know, but it's just.
you didn't write it down?
I wrote it down. I did.
So you took a picture in case you wrote it down wrong?
Yes. Because I didn't do it exactly like that. I wrote it down in what's making sense in my head right now. But then.
You're stressing Aslan out.
No intent there. Here's a question for you. Could I write that as the natural log of the square root of 20? Is that allowed?
Mm-hmm.
Yeah, that's allowed. And you'll see that come up like, say that had been a 25, for example, right? Then you would want to use a square root because, right, so for example, say you do your work and you end up with, x is 1/2 of the natural log of 25. You would agree that this is less simplified than doing this. That makes sense?
Yeah.
So in this case, I don't know, log of root 20, I don't know if that's more simplified. This seems better to me.
I agree.
All right. Want to do one more together? We got to do one more together.
I don't know about
You
that.
guys really want to.
Yeah.
Look at B. B is short. And we're done in like a minute here. So this is a quick one to end the day. E to the 2x
You just
minus 1 equals 80. This is question B, right next to that last one. First step,
subtract 1 or add 1.
add the 1 over. Now what?
The natural log of E
Natural log of,
Doesn't it go to ln?
of 81
Natural log
equals.
of 81 equals.
here's something maybe to have jotted down on the side, maybe. If you have e to the a power equals b, that's the same as writing natural log of b equals a. That transition is something that you probably got to practice a few times before it becomes natural. Right? That make sense?
Yeah.
This says log base e of b equals a, so e to the a power equals b, which is what that says. So that's what we did here. Make sense?
Yep.
Okay, now move that 2 over. So multiply both sides by 1/2.
So why isn't this just ln of 9?
It is.
Okay.
So now that 1/2 becomes a power.
I think we're gonna be okay.
We're going to be okay. And so this one actually does warrant that final step. Because, I mean, that's kind of beyond dispute that this is a much simpler way of writing the number than this. Okay? Yay.
Yay.
Aslan, deep breath.
Great.
Those really hurt my feelings. Like.
Which one?